So we're about ready to strike an arc here, and what we're going to do today is we're actually going to do 3 welds. We're going to do a MIG root to cap with hard wire on the root, and then a hard wire fill-in cap. The root pass will actually be a modified short circuit, and then we will go to a pulse spray mode as we fill. Now, one of the things that's really unique about our system is we actually have 3 gas solenoids on the Redi2Weld. So we're going to have a gas for the MIG side that would give us a gas for rooting, probably 75-25 on most situations. And then before we go to that fill-in cap where we're going to want to get into spray mode, we're actually going to switch over in the system through a solenoid that gives us 90-10. That allows us to weld from root to cap on the fly. As soon as it crosses over, if we want it to go directly from the root into the hot pass, it will do that. That's simply a setting on the system, and it will switch the gas solenoids whenever it ties in. So you don't even have to stop to look at the root. Now, I'm an old school guy. I think maybe you might want to stop and take a look at that root. I know for welding with the 70S, sometimes you want to wire wheel the toe to make sure there's no silicate trapped. But we have a lot of our clients who are welding root to cap with no issues. So that is up to you as the operator. You can run this root to cap without any issues. Then on the TIG side, we give you another solenoid, obviously, to run your argon. All of our solenoids are controlled by a digital flow meter. So you're going to set a flow rate that you want, and it's going to monitor that all the while you're welding. This keeps you from having to look back and make sure your bottle's in good shape, that you've got the right flow on a ball. It's going to show you that right on the screen. If it drops below a certain percentage, it's going to fault you and it's going to shut down the weld. So let me show you how the fit up works on this, because this is not a really unique fit up. We wanted this to be real world. So these pipe coupons were actually cut on our Watt Specialties pipe profiler. This is a burned on bevel. Now we do cheat. We get them sandblasted because we don't want to grind and clean them up ourselves. But all we've done here is we've tacked them up with a knife edge bevel, and then we feather out those tacks because we're going to reconsume those as we're welding. We want to have on the MIG side anywhere from a 332 to a 532 opening. If you can keep us in that range, you're going to be fine. On the TIG side, we're typically going to tighten that up a little bit. Let me show you the TIG side. This is a 4-inch Schedule 10. We have about a 1/16 root opening on this. So the idea behind this is that you don't need as much root opening for that TIG side. On a 4-inch Schedule 10, we can actually give you a 1-pass weld with reinforcement on the ID and the OD, again in 1 pass. So a 4-inch weld takes about 4 minutes. It's extremely fast. It allows you to really step up that productivity. All right, so we're about ready to strike this thing off. We're going to be welding a 6-inch Schedule 40, and again, we're going to go root to cap with this. This will be hardwire root to cap on the MIG side, and the next weld we're going to do will be a TIG root with a MIG fill-in cap. Reagan, if you're ready, I'm ready to weld. So we struck off here, and we're using a process from EWM called root arc. I don't know if you can hear that through the microphone or not, but it is a very soft arc. It gives you a lot of control. It's a very precise root waveform that is very forgiving as well. You can see in that arc view, we're oscillating right to left. And you can see from the arc view if we're penetrating on the ID as well. Now we're going to be running at about 3.5 inches a minute of rotation speed on this. When we go to our fill and cap, obviously we're going to speed up quite a bit. Now looking at the ID, we're getting a nice penetration. We're not overly penetrated, but we are consuming the sidewalls. And now we're in a tack. We're actually reconsuming that tack and moving right on past it. So I'm going to take a step back here, and we're going to take a look at what Reagan's doing while he's welding. So the operator view here, Reagan can see what's going on in the arc. He can see if he's penetrating through and consuming that edge of that bevel. You can see right there we've got a little bit of high-low, and it's consuming that. And it's a nice consistent oscillation weave. Coming into a tack there, it will reconsume that tack, and you'll actually see that happen as it comes across that tack. So coming to the end of the tack, you'll see it reconsume right there. So we reconsume that tack. That's why we always want to stress on the fit up side, we want to have really good tacks, because a good tack is going to stay there. Put a bad tack in, we're going to reconsume it, but you're going to have whatever was bad in that tack remaining. You can see right there, we're actually getting a lot of fill on this root pass. Again, we're running at about 3.5 inches a minute. So when this finishes on the root, if Reagan has it set this way, it's going to step right into that hot pass. But he may have it set to where it's going to stop so we can take a look at it. He's shaking his head yes, so that's what we're going to do. Now, if you'll notice here, Reagan's hands are not real busy here. He's attentive to what's going on, but there's not a lot of activity going on from the operator perspective. That's on purpose. We don't want them having to change a lot of things. That's why we stress consistency and fit up. If your fit up is going to be consistent, then your welds are going to be consistent. Well, again, what we're looking for again is a 332 to 532 root opening. That Xyrus camera gives us a nice clean view. On the readout there that Reagan's looking at, he can see that our heat input right now is running about 23 to 24 kilojoules per inch. We've got our current showing up there, wire feed speed. We are running 045 wire on this, and it's a 70S6 wire. So we're about to tie into that root pass. As soon as we tie in there, Reagan's going to allow us to take a look at that. There it ties in, shuts down, and we'll rotate a little bit and let you see what that root looks like. Really consistent sidewall fusion there, very consistent bead. That's what we're looking for. We want that root to be very consistent. So now we're going to advance to the second pass. He hits the strike button from here. And we again are in a pulse spray mode. So from EWM, this spray mode is called Force Arc. And that is a very, very defined puddle that you're going to see there, or arc. See how the sidewalls of that arc are very vertical? It's giving us very concentrated heat, allowing us to have really good sidewall fusion, and also a lot of control over the puddle. So we're going to cap this on this pass, and you're going to see that we have full reinforcement ID and OD, and we're able to do this in 2 passes. Right now we're running about 8 inches a minute of travel speed. If this were a heavier wall pipe, we could actually ramp that up a little bit more. We're running 285 inches a minute of wire. I'm gonna step back around here to the arc side of this. Looking at the ID here from my perspective, I know you probably can't see it well from the camera, but that root is in there nice. It's nice and convex, but it's not overly penetrated. Again, we've got 3 slides here on this system. We've got our oscillator here. That's giving us our walk in the cup feel on that pendular oscillator. If Reagan needs to steer right to left, that's that horizontal slide, and it's monitoring the arc gap through that vertical slide all the time. One of the things we haven't shown you on this system is that entire weld cart is motorized with a rack and pinion drive with a servo motor. So it allows us to drive up and down this rack. This particular client's system is going to be 50 feet long, so they can weld double randoms. So you can simply drive this up and down. On that cart, you actually have room to put a drum feed system. So if you wanted to run drums as opposed to wire spools, that's no problem. That is built into the system. You have the room to put that there. Okay, Reagan, if you would, let's rotate that around. And you can see right there, we've got a nice cap. We did that in 2 passes. So we're going to swap this out now. So now we've swapped out these torches. We've aligned our torch to the center of that joint, and you can see if we do the camera, the picture-in-picture, you'll be able to see that our tungsten's aligned over that gap. Now, one thing I wanted to point out about our column and boom that I hadn't covered before, the vertical adjustment on that is mechanized. The in and out is on a rack and pinion. It's also mechanized. So from an operator perspective, you can control everything, like I said, from that remote pendant. I can go up and down with the column. I can rotate the column. I can go in and out with the boom, all from that remote pendant or from the operator console. Now then, we put our TIG torch on. It will automatically switch over to our argon regulator so that we're going to be in the right mode. It's going to give us the right gas. Like I said, we have 3 solenoids on this system. We've got another carbon steel 6-inch schedule 40 here. It has the same type of root opening. It's about 332. We're going to start off on attack, whether we're in MIG mode or TIG mode. So he's going to start off on attack. This is going to be hot wire TIG, so it's going to bring some heat on that wire before it hits the puddle, getting it to what we call a plastic state. It brings it almost to the melting point, but not quite. That allows us to use that arc plasma to weld and not have to melt that wire coming in, so it really gives us a higher deposition rate. Reagan, when you're ready, I'm ready to weld. So we're getting sidewall fusion on both sides. And as we look at the inside, we're getting reinforcement to the ID as well. Now, one of the advantages, obviously, of welding with hot wire TIG is we're going to weld cooler. We're not going to have near as much heat input. So if we wanted to weld this root to cap, we could, and we wouldn't have to stop in between passes. We find a lot of our clients on Schedule 10 stainless really enjoy that feature because they don't have as much heat going into the weld. They can get that done without having to break the arc. You can see from that arc view camera, you're getting nice sidewall fusion, laying in a very consistent bead. And as we come over tacks like that, we reconsume that tack, and then it just keeps going as it comes off of there, tying into that sidewall. So when you look at the inside, the tack is not very visible. So stepping back here so we can see what you're going to see from an operator perspective. So Reagan's got that camera looking at the leading edge of the weld. He can see that he's breaking down the sidewall, getting penetration. Our heat input's running about 22 kilojoules. And we've got about an 11-volt arc gap. Now, because this is an open root carbon steel weld, we're not actually using the O2 sensor. But if we wanted to use the O2 sensor on this, if it were a stainless weld, we could set that to where, again, it would monitor that oxygen content on the ID as we're purging, and it would not allow us to strike the arc until we'd hit the value we had programmed into the system for a minimum of 5 seconds. So you can see it opened up a little bit there on that arc gap. Reagan's just driving right through that. Again, these are burned on bevels. This is as real world as we can make it. See, we're coming up on another tack here. Looks like. No, I guess it wasn't. I guess that just opened up a little bit there. And again, the system just welds right through that. So here's another tack. Coming right off that tack, you can see that we reconsume that, and it just keeps going. I'm going to step back around to the arc side of this. One of the features we wanted to build into this system was durability and the ability for you to weld in case something goes wrong. That camera system is a critical part of this system. It allows you to weld without having to stand over the arc, but if that camera system goes down for some reason, somebody bumps a piece of pipe into it, things break, if it were to go down, you're not shut down. With any of the other systems out there in the market today, if the camera shuts down, you can't weld. We didn't want that to happen in our systems, so we made this camera something that if it did go down, you can simply pick up that remote pendant, put a hood on, and you can keep welding at the same productivity. Obviously, that camera really helps from a safety perspective, keeps you away from the arc, but we didn't want a lack of a camera to keep you from welding, and that's what we built into this system, something that allows you to keep welding no matter what happens. So he's gone right into the hot pass here. And then what we're going to do after this pass is we're actually going to swap out. So let's say that you had to put in a TIG, root and hot, and then you could fill and cap with whatever process you wanted, flux core or hardwire. That's what we're going to do here is we're going to swap out and go to a MIG weld or MIG cap so that you can see how easy that is. Now on 6-inch Schedule 40, quite honestly, we're almost capping it anyway when we do this hot pass. That root is nice and consistent. Again, not overly penetrated, but it is reinforced. We did reconsume that bevel, or consume the edge of that bevel. This system stepped into that hot pass, and you may not have even noticed, but that oscillation path got wider, the speed of rotation increased, and our wire input or wire feed speed increased substantially. step back around here to where Reagan is. As he's watching this, he can see that he's tying into that sidewall, getting into the toe of the weld on that root pass, and it's very consistent. Right now he's feeding 100 inches a minute of wire. This is 035 wire, and he is running at about 170 amps. Our heat input's only running in the low 30s. Now with TIG processes, obviously your travel speed's not going to be as high as it would be with MIG. So he's only running about 3.5 inches a minute. But you can see on a second pass on an open root 6-inch Schedule 40, he almost has this thing capped out. Stepping back around here to the other side, I wanted to mention a couple other features on this front end that I hadn't covered yet. Let's say you're doing a slip-on flange or you're doing a socket weld of some sort. Our system is designed to allow you to tilt the entire welding front end of this, all 3 slides, in the axis that you need to be in for that particular weld. So let's say we want to do a socket weld or a slip-on flange and we're doing the back side of that flange. We need to tilt this entire mechanism at a 45-degree angle. When we do that, all of our slides tilt as well, so that when we're adjusting for arc gap, it's adjusting in the right plane. That makes this very simple to do both the back side of a slip-on flange and then come around and do that ID. We're going to swap out this torch. Now that we've got that aligned to where we want it to be, that's all it took to switch over from MIG to TIG. It's simply changing out that torch, driving it back over where we want it to be. Just imagine if we had 4 or 5 welds in a spool. We would go through and put our root and our hot pass on all of those. Then we would swap out those torches. We could come back and fill and cap. Obviously, if we're doing heavier wall, you're going to have multiple passes on the MIG side. If you wanted to run flux core, that's not a problem. Any of the MIG processes or wires We can go flux core, metal core, solid wire, it doesn't really matter. How many times while you're welding do you get to drink a cup of coffee? So Reagan right now is putting in that split bead cap. You can see we have just a little bit of oscillation there on our cap pass that we're putting in. We're running 10.5 inches a minute. We're running about 195, 200 on our current, and our wire feed is 285 inches a minute. Heat input's running about 28, 29 kilojoules. Again, if I want to record all this data, there is an option with these systems that we can put on what EWM calls XNet. We can pull all the data from this weld, your wire feed speeds, your amperage, your voltage, your travel, all of that can be pulled and give you that so that you can supply that to your clients or use that for validation of staying within your parameters. So I'm just going to step over, put that other bead right next to it. As I said earlier, that camera is water cooled. Down in the lower left-hand corner, you can see that that thing is only running at about 91 degrees Fahrenheit. So it's got a refrigerated water cooler on it that's keeping it nice and cool. 100% duty cycle on that, obviously. We're about to finish this weld up. There we go. We've now done a TIG root and hot with a MIG cap. Obviously, if we were doing 6-inch schedule 80 or schedule 120, something like that, we'd be adding more passes. On a 6-inch schedule 40, a lot of our clients would just simply weld this all the way out with TIG. But that shows you the flexibility of the system. We can change over in just a couple of minutes and allow you to have that combination. A lot of our clients are required to put in a TIG root and hot or stick root and hot, and this gives them that flexibility. Redi2Weld's the only one in the industry that gives you that functionality. So now we swapped out from MIG mode to TIG mode, and we're going to do this 4-inch schedule 10 stainless with an open root. Now we're going to get this in one pass. So some of our clients, understandably, their end user will not allow them to do a single pass schedule 10 weld. That's okay, we can do 2 passes, But we get a lot of questions, can you do this in one pass? And the answer is, yes, we can. So we've got an open root here. We actually cut these on our Axe-Air saws and then beveled them using an Axe-Air as well. So we've got a nice consistent bevel on these. They're 37.5 degrees. And the opening is right about 1/16 of an inch. They're feather edge. We tacked them together, then we feathered down those tacks so that we can reconsume them. We've swapped out the torches, gone from MIG mode to TIG mode. We're purging the ID. And I think that we're ready to weld. We've got a nice consistent oscillation here. Kind of into both sides of that joint. And with this particular setup, we can actually look at the ID. I know that's not realistic in the field, but I can see inside that we've got a nice consistent penetration. We're getting reinforcement. And our color's really good as well. That popping noise that you hear on that wire, that's actually that hot wire TIG that we're talking about, mixed with that wire oscillation that we discussed as well. That allows us to break that current, so it actually gives kind of a short circuit feel to it. We're running about 3.5 to 4 inches a minute on rotation or travel speed. With our heat input, it calculates out to about 18 to 20 kilojoules. We'll go check that. So our kilojoules on this are actually running about 14 or 15, so we're running really cool. And you can see from Reagan's perspective here, his perspective shows that he can see that he's tying into both side walls. He's consuming the edge of that bevel. And again, what I want to stress is if you can see his hands in this picture, he's not doing a lot of work here. He's letting the system do the weld. Stepping back around to the front side of the system, we have a lot of clients who will actually cut their Schedule 10 pipe using an Axe-Air saw and tack it directly to the fitting or go with an open root to the fitting, thus removing that extra step of beveling. Lots of different ways clients use this system to meet their specification. Again, looking at the inside, we've got a nice consistent root, getting reinforcement. And our color's good. So we're about to come back around to that tie-in. So that's all it takes for a 4-inch Schedule 10, one pass, fully reinforced weld using hot wire TIG. Running that weld in about 4 minutes. So again, we've shown you MIG root to cap, we've shown you a TIG root and hot with a MIG cap, and now we've shown you a hot wire TIG 4-inch Schedule 10. All of that with this system, all of those changes can take place very quickly, very easily, and it's a very repeatable, user-friendly system to plug into your operation. Thank you for your time today. We appreciate the opportunity to show you our Redi2Weld combo system.